All right, all you AP1 physics students, I've got a new sheet for you. Hopefully you're able to solve the ones on the old sheet relatively well. The sub will pass this out to you on Monday. I wish you the best. This will give you a chance after you work on this sheet to finish up on your WebAssign that you printed, which is the remainder of Chapter 1. You'll see it posted on your WebAssign. Please bring that in on Monday and Tuesday and work on that while I'm not here. So this particular sheet starts out and it has 6.5 kilometers at 90, vector B is 11 kilometers at 35, C is 9 kilometers at 148, D is 5 kilometers at 312. What I'm going to do now is throw away the ruler. No more protractors, no more rulers. We have to be able to visualize these inside our head though. So what I'd like to do is just roughly draw out our very first one, which is vector A plus vector B. Okay, and we're going to get some result out of that we'll call the resultant. Let's see what that looks like. So we start out at 6.5 at 90. So 6.5 at 90 is going to kind of head up this direction. So we've got 6.5. This time it's in kilometers. You know, who cares? Meters, kilometers, miles. We're still going to draw the arrow, relatively speaking, just something to scale. All right, now when we look at B, 11 kilometers at 35, we're going to place it head to tail, of course, because we're adding, at 35 degrees. I'm going to just kind of roughly say that. Now 11 is longer than 6.5, so I'm just going to draw it maybe a little bit larger than what I had here. Now if I look between base camp and the snake pit, if we actually look at this, we're going to end up with some kind of answer. Goes from base camp all the way out to the snake pit, and it's going to be some kind of line that kind of looks like that. So that's going to be our resultant answer. So let's set this up. All right, remember, this is monkey work. So if we think about it, it's monkey work because basically we're going to do the same thing each and every time. Now in the x direction, we always know that we're going to use cosine, and in the y direction, we always know that we're going to use sine. We have two vectors, A and B. I'd like to do the very first vector A first. So vector A is 6.5 kilometers. So what do I write in front of cosine? I write 6.5. What angle is this vector A at? It's at 90 degrees. I'll just put 90 degrees in there. Sine of 90, we're looking here. Voila. Okay, now let's take a look at vector B. All right, so we're going to add it. So that's what it said to add. So vector B, we end up with 11 kilometers. We know that it has to be cosine for the x, sine for the bottom. All right, because it has a magnitude of 11, put the 11 here. What's the angle of the 11 kilometer vector? And it's 35 degrees. I'll place that right so. Okay, so if we look here, we place those in there. Now, I know what you're thinking. 6.5 kilometers is 90. It doesn't have any x. So I bet you, if we plug in our calculator, the cosine of 90 actually is 0. 0 times 6.5, this term is going to get eliminated. In the y direction, sine of 90 is 1. 6.5 times 1 is, well, gee whiz, doesn't have a lot of y, it has 6.5 of it. So what I'd like you to do now is plug in those numbers and get me the movement in the x and y direction for this very first problem.